Hello, testing, testing. Mic a little bit closer, maybe. Okay. Hello, good morning. Or afternoon, or evening, wherever you are. We're doing more Google interview questions today. We're going to be doing the one question that got us yesterday. Again, the one that took us an hour and a half to do. And then we're going to do its sequel next, hopefully. Hopefully it doesn't take an hour and a half again. Okay, so Leetcode 3349. Leetcode 3349. Okay, adjacent increasing subarrays detection 1. Given an array, GetArray says, hello. Hello, how you doing? I am doing the problem that got me yesterday. Hopefully, it will be better today. Given an array nums of n integers and an integer k, determine whether there exist two adjacent subarrays of length k such that both subarrays are strictly increasing. Specifically, check if there are two subarrays starting at indices a and b, a less than b, where, okay, a to k minus 1 and b to k minus 1 are strictly increasing. Okay. Return true if it is possible to find two such subarrays, false otherwise. Okay. Let's not do it the way we did it last time, right? That was so inefficient. Or, it was pretty efficient actually, but it was just too long. I'm going to be writing some pseudocode. Okay. What do we need to keep track of? We need to keep track of the current ascending subarray, I guess. It will equal to 0 in the beginning. What else? Do we need to keep track of the last ascending subarray size? It'll equal to 0 by default too. Okay, what else do we need to keep track of? I feel like that's it for now, unless I remember incorrectly. And then we go through the array from start to end, right? If, what do you do here? So if the start, well, let's say we're starting from here. If my current one is greater than my previous one, then I add to my current ascending subarray count. Yeah, okay. If it's ascending, keep adding to the ascending count. If it turns out it's decreasing, then, excuse me, then what do you do then? The current ascending subarray count is now equal to the last one, and then we start over. Okay, sure. Yeah, I think that works. So here, 2, 5, 7, 8, 9, we would get 5. And then after we get to 2, the last ascending subarray would now be 5, and then we reset it to 0. And then 2, 3, 4, 2, 3, 4. This would now be 3. Yeah, I think this works. And then 4, 3, we would reset it to 3 and then 0, 3, 1. Okay, so this enforces the adjacency thing. Last ascending subarray would become 0 now, and we reset this back to 0 as well. Okay. Yeah, I think that works. And then we need to keep track of 2 cases too. So there's like 2 adjacent subarrays, or they're just one huge ascending subarray. Yeah, okay. 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 And then I think in the solution last time, they were like, the min of these is equal to k, which makes sense because they both have to be greater than or equal to k. And then one huge ascending is, if you divide by 2, it's equal to k. Okay, cool. I think I have an idea how to do this now. So int current ascending count, let's say count, is equal to 0. Int last ascending count is equal to 0. Okay. I think this could work. And then for int I is equal to 1, I is less than nums.length I plus plus. Okay, now we need to compare the current integer to its previous. So if nums I is greater than, it has to be strictly increasing, right? Varnit says, do you try to solve questions on your own without any help? Oh no, help is okay. Usually what I do is, if I can't figure it out in like 10-15 minutes, I take a peek at the solutions. Gabriel says, or int n is equal to nums.size. Oh yeah, this happened last time too. Thanks, Gabriel, because it's a list. Nums I is greater than nums I minus 1. So this is the case where I'm bigger than the previous. So then you would increase your current ascending count. Barnett says, I try to solve questions on my own, but I can never come close to solving it. Oh, that sucks. I'm sure if you practice more, try more, eventually it's gonna come to you. I mean, if you never come close to solving it, then at that point maybe it's okay to look up like some hints or even maybe solutions, I feel. Because then otherwise what are you gonna do, right? But yeah, that kind of sucks. I kind of feel that. Okay, so if my current number, if I'm bigger than my previous, I add to the current ascending count. So current ascending count plus plus. Okay, let's leave that for now. Let's do the opposite case. So if I'm descending, then I set my last ascending count to my current, move everything over, and then I reset my current ascending count equal to 0. Okay. Okay, there's a couple checks that we need to do when it's ascending. So we need to check if there's 2 conditions for success, right? Either the previous subarray is greater than k, the last ascending count is greater than or equal to k, and the current ascending count is greater than or equal to k. Or my current count is k times 2, because then we have one huge increasing subarray that we can split in 2 to make k. Yeah, okay. I remember in the solutions last time, they did some really complicated min-max stuff here. I don't think that's necessary. That's just confusing to me, though it makes sense. So if the last ascending count is greater than or equal to k, and my current ascending count is greater than or equal to k, then you return true. Okay, and then there's another case, right? We will add an or statement here. The other case is if the current ascending count divided by k is equal to 2. I'm so worried. Is it gonna floor division this? I feel like it's gonna floor division this. I mean, wait, actually, is floor division gonna affect us here? If it's like, I don't know, 4 and 2. 3 divided by 2 is 1. Okay, then maybe not, because we're going in ascending order. Okay, it's probably fine. And then else, if you get through everything, you return false. Run. Let's see how many compilation errors we have. Oh, right. I keep thinking that this is an array, but it's actually a list, so we have to use functions instead. Is that the only place where I did it? I think so. Okay. Oh. There's another place where I did it. Run. Gabriel says, yeah, weird, the input is a list. I know, right? Alright, doesn't work. Time to do some debugging. Well, this thing is right. That's great. Well, is it just outputting false the entire time? That's not good. 257, 789, 234. Okay, I think it will be useful to print out what the current number is and if we think it's ascending and whatnot. So let's do system.out.println. The current number is nums.get I. And then if it's bigger, we'll print out that it's getting bigger. Manvic Bazaar says, hi. Hello, Manvic. How you doing? I'm currently doing an easy problem that's really hard. Okay, so let's print out ascending, and then let's also print out our current ascending count. And then else, if it's descending, we'll print out descending. Okay, that sounds good so far. Last, current. Is it worth printing out any of these? I feel like these are pretty straightforward, so I don't think we need it, so we just print out as descending. Okay, run. Okay, let's see what it got us. So current is 5. Oh. It should be 2 at this point, shouldn't it? At 5. Yeah, it should be 2 at this point. Ooh. Our current ascending count should be 1, no? Because we start at index 1 and we're always checking our previous. Monvic says, how are you? I'm doing good. I'm honestly pretty excited, I would say. I've got some exciting collabs coming up. Tomorrow in the morning, I'm gonna battle a NASDAQ data analyst again in a Leetcode battle. Oh, there's the promo. Yay. It's too big. His name is Nirino. We actually battled once and we tied, so this is gonna be a good match, I think. Yeah, I'm thinking about doing more battles in the future. Yeah, it'll be fun. I have exams coming up in 10 days. Oh damn, good luck, man. Oh look, it worked. Hey, let's go. Debugging does work, guys. Maybe I should keep these print statements in, just in case the submit goes wrong. Yeah, it went wrong. Yeah, good luck on your exams, Monvic. You got this. Current is 5 and it's descending. But I have not studied anything. Oh, why not? Why not study anything? K equals 1 is equal to true. Oh yeah, we did this base case last time too, right? I wonder how they handled it in... Huh, okay. Use test case. Yeah, okay, let's put a base case. So if k is equal to 1 and nums dot size is greater than or equal to 2, perhaps, then you return true. Run. Nice. Submit. Let's go. This was way faster than last time. Delete these. Delete these. Yeah, thanks, Kiabre. Cool. Oh, okay. This is way more elegant than last time, holy. And way more understandable than last time too. I like this. Yeah, I like this. How did the number one solution do this? Oh, my brain. I don't like this. Okay, I imagine they're also doing continue. This is the current. Deepak says hi. Oh, hey Deepak, how you doing? Okay, I think they're doing something similar to us. This is the current one, and this is the previous one. The previous count, they start at 1. If nums.get I, okay, then current plus plus. Oh, okay, so they do the check. They do the check when it ends. That makes sense. Previous is equal to current. Oh. I'm gonna try this. We don't need like a base case over here. So what they're doing is they set last ascending count to 1. So if the first one ends, it's counted as a 1. So like we start from here, right? This is counted as length 1. Our last ascending count is counted as 1 too, because 19. So we just hard code that. Last ascending count is 1. So when we get to 5, that's length 1. We check our previous, it's 19. Okay. Okay. So let's move the check to when we end the ascending subarrays. Yeah, okay. That way we're guaranteed to check them when they end. But yeah, on second thought, what's the point of checking it here? We should only check it when we end it. Oh, hi Marissa, hello. How you doing? Okay, what was I planning here? I forgot. If descending... Okay, let's run this. Cool. Okay, and I imagine this could make it a lot faster too, because we're only checking it if it descends. My hand is fixed again. Hey, let's go. Yeah. You also need to check it at the end. Oh, yeah. It doesn't know it ended at the end, does it? It doesn't check it. Got you, okay. Because at the end, it just exits out of the loop. It never reaches here at the last loop. Got you, okay. So I just returned this, right? Okay. Oh. What is going on here? We're really close to, though. 1420 and 1422. K is equal to 3. Okay. What's going on here? I would really appreciate the print statements again. Okay, well, time to manually type them in again. System.out.println. The current is equal to nums.get I. System.out.println. Let's print when it's ascending. Plus current ascending count. And then when it's descending, should we print out anything over here when it's descending? Oh, I'm going to use the test case, by the way. So, descending. Okay, let's see what we got here. Okay, let's run this. So everything is descending so far. From here to here, it's descending, ascending here, whoop, descending here. K is 3, so we're ascending here, here, here. Oh, okay, I see what the issue is. 2, 3, 4, 5, 6, 7, 8, 9. Oh, shoot. I see, okay. The equals here doesn't work here. We can't check if divide by k is exactly equal to 2, because it could be really huge like this, so maybe if we do like greater than or equal to 2, because if we chop it up into, well, I think conceptually it makes more sense to me if divide by 2 is greater than or equal to k. Because if we divide it into 2 pieces, both pieces have to be greater than or equal to k. Yeah, okay. Run. Nice, okay. Submit. No, why? Dude, we're like really close though. We're only one test case away. 1421 out of 1422. Okay, that's okay. We'll use the test case again. We'll run it. So we expected true, but we outputted false. Okay. That is a lot to read. Okay. So k is equal to 3. Okay. 3. It's here, isn't it? It's here. Okay, I know it's wrong again. Again, we can't do directly equals to 2. So we do divide by 2 is greater than or equal to k. Run. Yeah, Bray says your own solution of the base case was better. Is it? Hey, let's go, it worked. Yeah, I think in some ways I like my old solution better. But I do think it's kind of cleaner without the base case. But the con is we gotta check the condition again at the end. Okay, let's submit again. And it beats 100%, woo. You know, maybe this solution's better, it's faster. Because we only check the, end condition when we're, not ascending anymore and not on every single element in the ascension. Okay. I'm still gonna mark this question down for review. This is actually difficult to think about. But hey, we got 100%, woo. Yeah, I'm gonna double star this question. But yeah, yeah, the next coming weeks are actually pretty exciting. So again, tomorrow in the morning, I'm battling Nerino, who is a real NASDAQ data analyst. Next week on Saturday, I'm gonna battle Circuit Breaker again. In case you don't know who Circuit Breaker is, Chet, spinny eyes. It's this girl. She is a real CS major. We're doing a rematch again. This is one of the most stressful coding battles I've ever been part of. And then the week after that, I'm thinking about doing a big collab with multiple people. It's not just 1v1 anymore. It's, kind of like a battle royale. Many people Leetcoding at once. Yeah. Okay, next problem. We got this one. Okay, time for the next one. The sequel of the problem we just did. 3350. Leetcode 3350. Mer says, no, I won't be able to be there because I have therapy then. Sorry. Oh, no need to apologize. Good luck at therapy though. That sounds important. Oh boy, okay, a medium question now. Given an array nums of n integers, your task is to find the maximum value of k, for which there exist 2 adjacent subarrays of length k, each such that both subarrays are strictly increasing. Okay. Specifically, check if there are two subarrays of length k starting at indices a and b, a less than b, where, okay, this is the same as the previous problem so far. Return the maximum possible value of k. A subarray is a contiguous, non-empty subsequence of elements. Okay. Noir says, stumbled upon you randomly just now, lol. I'm prepping for a meta interview this week and this looks very fun. Hey, good luck on your meta interview. Meta and a bunch of FANG companies are really hard to interview for. Okay. Is there guaranteed to be multiple solutions, or could there be multiple solutions per array? 257, 89. Oh, this 2 could be a solution too. So many people found me by misclicking. Thank you, YouTube algorithm. Okay, what is our strategy here? I think we can do it like the previous problem where we maintain the count of my current ascending subarray and also the previous increasing subarray. And then, okay, so whenever a increasing sequence ends, we need to calculate our best solution so far and then store it. And the best solution is, like last time, I guess the minimum of the two subarrays lengths. Okay. Or it's the biggest one divided by 2. Yeah, okay. Because there could be just one giant increasing subarray that we can split into 2. Okay. I think I know how to do this. Or I have an idea. It's pretty vague, but I think we can do this. So we have int current ascending count. We'll begin it with 1 again, sure. And then int, because we're gonna skip the first number because we're gonna keep checking the previous. Every number can stand for itself. And previous ascending count is equal to 1 from experience. And also int best solution is equal to 0 so far. Maybe 1? Sure. Nums is guaranteed to be greater than 2. Okay. Yeah, so our best solution worst case is 1, just the 2 numbers side by side. Each one is its own increasing subsequence. Okay, so we go from 1, index 1 to the end, int I is equal to 1, while I is less than nums dot size. They gave it to us as a list again, I++. Okay, so if what? If I'm bigger than my previous, then we do a certain set of things. If nums.get I is greater than nums.get I minus 1, aka I am ascending. I am ascending. Did chat maybe hack the YouTube algorithm so everyone misclicks on a chat video? Wait, I mean, that should be a question for you guys, no? How'd you guys even misclick on my video? What kind of video did you think it was? Oh, I know. Or were you guys trying to click on the video next to it, but then due to inaccurate aim, you clicked on mine instead? But yeah, how did you guys click on my video? That's what I'm wondering. So if we are ascending, we increase the current ascending count by 1. Plus plus. And then else, that means I am descending. Gabriel says, I just liked your avatar, then liked your content. Ooh, thank you. Where's my avatar? Oh, here it is. Yeah. My avatar. A lot of people don't know this, but I have eyes in the back. This avatar was... Oh, Marissa says, I wanted to click on a ultra kill video, I think, which is basically doom and death and murder. My mouse was like, how about I give you 2x sensitivity? Then my mouse went a video more down. Oh. Ultra kill video. Ultra kill. Ultra kill. Oh, it's like a game. Noir says, wasn't a misclick for me, but I didn't know V2 plus coding could be combined. Oh, wait, it can. There's like several VTubers I know that code too. Actually, hold on. But yeah, well, I guess they don't do it all the time, but I have done collabs with a lot of other VTubers that code. It's not their main shtick though. There are VTubers that code as their main shtick though. Yeah, no problem, Marissa. Okay, so if it's descending, what do we do? That's when we update our best solution, right? Best solution is equal to... Okay, so it's either the minimum of the two sequences we just evaluated that are next to each other, the minimum of them. That's the K. Okay, so math.min current ascending count, comma, the previous ascending count. We also need to track the one huge ascending chunk divided by 2, right? Should I just worry about that later? Wait, actually that's kind of easy. So math.max. Oh, so that's what they were doing with the max thing. So it's either this one. It's either the max of forming it with 2 smaller subarrays, or the max of the max of the same thing divided by 2. This divided by 2. 2. I'm gonna label this somehow in a good way. How do I label this? So this one here is 2 subarrays combined. And this one here is one giant subarray split into 2. Yeah, okay. And then in the end, you return... Is this gonna have... Do we have to check at the end too? I imagine we do. Because... What if it's ascending all the way to the end, right? Yeah, what if it's ascending all the way to the end? Then we never descend, and we never check our best solution, so... We should probably update our best solution again at the end. Okay. That's kind of a hassle that we're duplicating the code, but it's probably fine. And then we return best solution. I predict this is probably not going to work and we're going to have to debug a lot, but Here goes our first shot. Compile error. Expected, oh, semicolon. That means it's the same here too, semicolon. And also we have our redundant parentheses. Hopefully this works. Okay, we're getting somewhere. 3, 3, okay. The first one is right. We're outputting 3 on this one, but it should be 2. Oh. Okay. This is going to be a pain to debug. Expected 2. How are we getting... Where are we getting the 3 from? Oh, time for debugging. Pain. Okay, so like last time, I think it's useful to print out which number we're actually processing. Let's print out nums dot get I and label that as the current. If we're ascending, let's say we're ascending. Ascending plus the current ascending count. If we are descending, then sure, let's print out we're descending. Descending. Oh, I see one thing that we aren't doing. We are not resetting the... Dang it, we are not ascending the... Sorry, we are not resetting the current ascending count and the previous count. Ooh. Previous ascending count is equal to 0. No, the current one. And then reset the current descending count is equal to 0. My brain had a stroke trying to read that. No. Oh well, it's okay. We have... Oh. Alright, well, case 2 is working now. Noir says, I'm so completely lost on what's happening here, lol. Oh, okay. Current ascending count is equal to 1. Yeah, that's what we set it to at the beginning, because we're skipping the first... Well, for the beginning, we're skipping the 0th index, right? So it's automatically 1. Yeah. And then we're constantly just checking our previous, right? So if the current number, let's say for the first time we're checking a number, right, and it's greater than its previous, then that's 2. Oh, okay, got you. Okay. All right, what's going on here? So output is 2, we got 2. Oh, okay, that's good. Nice, okay. What about case 1? What's happening with that? Expected 3, we outputted 1. Expected 3, outputting 1. How are we getting... Why are we expecting 3? Where are we getting that from? 2 is descending. 2, 3. Are we not checking here? Ascending 3. 2, 3, 4, 5. And then here, we should be doing 2, 3. So over here, we're getting 5, right? And then we're here, we're doing 3. So over here, we should be checking So why is this check not working? So we take the max of either the 2 subarrays combined, the current ascending count, the previous ascending count, or the current ascending count divided by 2. Like whichever is greater, the current ascending count or the previous ascending count divided by 2. Let's print out what both of these are, yeah? I think that will help. Yeah, I have a divide by 2 here. Okay. Ooh. Yeah, let's print out some stuff here. System.out.println. Let's print out our current ascending count. Whoop. And then our previous ascending count. That should give us some clues of what's going on. I'm just going to put a $sign here so we know we're putting out something special here. Okay, here, so yes, our previous is 1, ascending is 5. Okay, 3, 5. Okay, so we're recognizing that our previous is 5, our current is 3. So why is the best solution not updating? Oh, I know. We're constantly overriding the best solution. Oh, we are not comparing it to the best solution in the past at all. We're not keeping the best solution if it's better in the past. So int, what do I even call this, local solution? The local solution is that, and then the best solution is equal to the max of which one is bigger, the current best solution or the local solution. Yeah. Okay. And it's still wrong, yay. Output is 1. Same at the end. Oh, same at the end. Thank you. So this is the local solution, the best solution. Please work. Yeah, let's go. Yo. Why is this solution so ugly though? Jesus. Output limit exceeded. Oh, that's okay. We just need to stop printing out garbage. That's a good sign though. Yeah, we passed a lot of test cases before we stopped. I'm just gonna comment all these out instead of deleting just to be safe for now. Let's use this test case and then run it locally first. Nice, submit. Oh, ho, ho, ho. Yeah, let's go. Woo. Ho, ho, ho. I'm pretty happy with 85%. Okay, let's delete all this. Do you guys want me to explain what I'm doing? I think only Gabriel knows what I'm doing. I think Noir was asking too. Okay. So the problem is, what's the, I don't know. Find, how do I even summarize the problem in words? Basically find the maximum, find the occurrence of two adjacent subarrays with maximum lengths, right? That are, you know, the same. Yeah, find the occurrence of two adjacent subarrays with maximum identical lengths. That's the problem. So we basically go through the array from 1 to the end, and we keep track of my current ascending count. Oh yeah, that's the thing too. They have to be, the elements in the array have to be strictly increasing. So we keep track of our current ascending count of numbers and the previous ascending count of numbers. So every time my current number is greater than, oh, Noir says you get it now. Okay, never mind then. Okay, I'll just speed through the explanation then. You increase your current ascending count if it's greater, and else if it's descending, meaning you stop counting. You update your best solution. Either you use the current subarray with the previous subarray, so take the min of the lengths, or you take, you know, one giant subarray and divide it by 2. In this case, you take the max, whichever is longer, the previous or the current, and then you divide that by 2, and then you update your best solution, and then you reset your counts. In the end, you have to do the same too, because it's not gonna hit this descending block if it's just increasing all the way through. Yeah, that's the weird edge case. If it's ascending all the way through, it'll never reach here, so we have to do another check at the end. Yeah. Oh, should I mark this problem down for review too? I feel like we didn't struggle too bad on this one, but given how much we struggled on the prequel, I think it's worth writing it down. 3350. Okay. Okay, what do we do now? Also, I just noticed for the first time, people, you can see how many people are online on Leetcode. 79. Can you guys see this too? There's 79 people trying to solve this problem too. I think it's time for some system design study now. We spent about an hour Leetcoding so far. Yeah, okay. Let me just get my PDF out. Switch the screen. Okay, so in case you're new here, this is the part of the stream where I'll be a bit more silent than usual, because I'm just reading and taking notes. We're really close to the end of this book. We were learning how to design Google Drive, the system design of Google Drive. Okay. I think we read the in-depth design last time, so I'll probably just review it again this time and make sure I understand everything. We reviewed this part a lot, so Noir says, I'm a bit confused about the edge case of say 1, 2, 3, and 4, 5, 6, for example. How would we decipher between the two arrays? Oh, yeah. So we have 1, 2, 3, and then 4, 5, 6. So we would just count this as a one giant ascending array. So previous ascending count. So remember, every time we see an ascending number, we add to our current ascending count. Oh, you figured it out. Nice. Very nice. Yeah. This is just 6. And then we divide that by 2 here. To get 3, yeah. Cool. Marissa says, show Noir your avatar in the middle, but turned 180 around. It is very important information that they don't know right now because they are new. Okay. Noir, Marissa wants me to show you something. She thinks it's very important. Okay, take a look at me, right? Eyes on me. Can you guys see this? Is this your treat for being a new viewer? Okay, sorry, I'll stop. Let me just reset my avatar. I still don't think I'm completely reset yet. Okay, that's probably good enough. And that's good enough, okay. Nice. Okay. Back to system design. Okay, so this is the whole shtick of Google Drive, right? This is the low-level design. So the user, when they upload a file to Google Drive, they go through so thick. I didn't expect that. Thank you. The time is 1:05. Okay. So whenever a user uploads a file to Google Drive, they go through a bunch of block servers, which basically cuts the file up into a bunch of blocks of tiny pieces. And then they can upload that in parallel to cloud storage. Oh, and this also helps if they're editing the file too. You can do a thing where you only upload the edited blocks of the file. Like, for example, if you only edited the last page, you only need to upload the blocks corresponding to the last page and nothing else, which is nice. And then for files that are not used very often, you can move them to cold storage. Cloud storage is like S3. Cold storage is like Amazon Glacier, AWS Glacier, something like that, where the storage is really cheap, but retrieval of information is really expensive and takes a long time. Okay, so when a user gets, all their API calls go through the load balancer to the API servers. When it's finished uploading in the cloud storage, it goes, I guess it notifies the API servers through the load balancer too, and then it updates the metadata saying, okay, this file is done uploading. And then it notifies the user somehow, either offline queue or notification service if they're online. Okay, so when a user gets a file, they go through the load balancer to the API servers, which fetches it from cloud storage, and then back to the user. Okay. Cool. Design deep dive, okay. Yeah, only the blocks that are needed are synced. We also compress the blocks, which lowers storage. Okay. High consistency requirement. Oh yeah, this this part was kind of dumb. They were like, how do we make sure that we support atom, how do you pronounce this? Atomicity, consistency, isolation, durability. Just use a SQL database because they usually have ACID guarantees. Basically, everyone sees the same thing at all times. Yeah. Consistent behavior. Metadata database. Okay. The upload flow. Okay, so the client, they do this in parallel apparently. They upload the file, the block server's uploaded, the cloud storage updates the file metadata in our API servers. They call an API to do this. The API servers sets the metadata as status uploaded, and then notification service notifies the, whatever other people that have access to the file that the file is changed. And then in parallel, they shoot off a API call to the API servers, to the metadata. Yeah, and then they set the metadata to pending. Okay. Noir says, I'm curious, are you a CS student or just learning these topics for fun? Oh no. Neither. I'm not a student. I already graduated. I'm job hunting right now. Yeah. Thanks, Marissa. Definitely not for fun. I don't think. Well, I guess there's some people who could study this for fun. Yeah, what's the use of studying for fun if you're not going to use it though? Yeah. So in coding interviews, they often test Leetcoding, which was what I was just doing, and then system design. Yeah. Okay, what is this? This is the flow for getting a file, isn't it? Okay, so the notification service notifies the client of changes. You get the changes from the API servers. That's apparently an API call you can make. The metadata DB. Oh, okay. The metadata DB tells you exactly which parts are changed, so you can get only the specific blocks corresponding to the change. And the client downloads the corresponding blocks from cloud storage. Yeah, okay. Okay. How does it return the metadata of the changes though? That's what I'm wondering. So this is we store a file like this. We also store a file version. with the block ID. Okay, so when we get a file, we can also look up blocks that correspond to the file version, I suppose. Okay, sure. Yeah, okay. So when we try to look up a file in our metadata DB, we get its ID, the file version ID as well. Okay. Yeah, okay. And then we can look up blocks that correspond to the file version ID. I assume these are the blocks that are changed. Okay. Long polling, WebSocket. Okay. How do we save storage space? Deduplicate data blocks. Okay. So if some data blocks are the same, I guess. Don't store them. Be intelligent with data backup. Set a limit for the number of versions to store. Okay, sure. Keep valuable versions only. Okay. Moving data to cold storage. Failure handling. If the load balancer fails, I guess have a backup one. Block server failure. Have backup servers. S3. Cloud storage failure. Have a backup in multiple regions. API server failure. Have backup servers. Metadata cache server failure. Have backup nodes. Backup here. Everything just have a backup, right? Metadata DB failure down. So if your master database is down, use one of your slaves as backup. If a slave is down, use another slave as backup. Notification servers failure. Okay, so you have to reconnect to the lost clients. Okay. If the offline backup queue is failed, backup queue. Okay. Now the wrap up. In this chapter, we proposed a system designed to support Google Drive. Okay, another option is we can upload files directly to cloud storage from the client instead of going through block servers. It makes file upload faster because the file only needs to be transferred once to the cloud storage. So, wait, I thought it's faster because it's in parallel. I guess it's not. The disadvantages of block servers. First, the same chunking, compression, and encryption logic must be implemented on different platforms. iOS, Android web. Oh, I see. We gotta implement the same thing on all platforms. It's error prone and requires a lot of engineering effort. Okay. As a client can easily be hacked or manipulated, implementing encrypting logic on the client side is not ideal. Okay, that makes sense. Is moving online/offline logic to a separate service. By moving present service out of notification servers, functionality can be easily integrated by other services. Okay, sure. The learning continues. Yeah, we reached the end of this book. I think there's one chapter we skipped though. We might have to do that next time. Alright, very cool. I think I'll call it a day today. Thank you to everyone who came. Thank you, Marissa, thanks Noir. Who else was here? Pradeep? Deepak? Yeah, thanks everyone for coming. I'll see you tomorrow. I'm doing a... Oh. I'm doing a coding battle with Nirino tomorrow, who is a real NASDAQ data analyst. Oh, thanks, Gibre. I forgot you were here. Yeah, that's all I have to say then. Thanks everyone for coming. I'll see you guys tomorrow for VTuber coding battle number 10, I think. Yeah. Bye. See ya. Bye, Marissa. Bye, Gebri.